Okay, so we now come to invited talk. I'm delighted to be able to welcome Alex Rudnicky. Alex is nearly as old as I am. I think he did his PhD just about a year after me, sometime in the late 70s, early 80s. Is that about right?
Just early 80s.
Oh, okay, maybe. Alex is a research professor at CMU, been working initially on speech and very early on got interested in dialogue, has written many interesting papers on dialogue, multi-agent dialogue, and also contributed to the community, in particular Ravenclaw was from Alex's group and has been very widely used for modeling dialogues. And I think Alex even had a hand in development of Sphinx and Pocket Sphinx. So I'm now talking simply to pass the time whilst he gets his computer going. Otherwise, I'll hand over to Alex. Welcome.
Thank you. It's one of those times where I think I'm on stage, so it doesn't matter, but then I notice I actually need my glasses. Okay, so what I'd like to do today is talk about some of the work we've been doing in the last while. And basically, we're trying to take what might be a slightly different view of conversation, something that came to the fore once we started to look at non-goal directed interactions. So just to quickly recap, there's, at least since I've been around for a while, the vocabulary has changed in these things. So there's one kind of system that was studied extensively, which we might call dialogue systems, and their distinguishing characteristic was that they were goal-directed. Specifically, there was a well-defined domain and a well-defined set of actions that the user could perform within that domain using speech. And that was great because you could, measure performance, like how often did the person get the right answer and so forth, how long did it take. And so that was great, but actually more recently people have gotten interested in conversation, and in particular what we might refer to as open domain conversation. So there is no specific domain, no specific topic, it's just talk. I like to kind of think of it as the stuff you did out there in the hallway or maybe in here during the break. You didn't really have a goal, or at least not the kind of goal the dialogue people would think of. Interestingly enough, these two kinds of systems have been around for a while. So there, for example, dialogue systems might be exemplified by the work done during the communicator program. But there are these older things like ELIZA that have been around for literally decades that have actually tried to do this more chat stuff. What I'd like to propose in this talk is that in real life, it's actually a combination of the two. When you're talking with somebody, you might be working on something together, so there's particular goals, but actually you're also trying to do social stuff. And some of it might just be, being nice. Other parts of it might involve other kinds of goals, like trying to be somebody's friend or trying to persuade them of something. And I think really in reality, when people talk to each other, there's a mixture of these things. It's been easier to just tease them apart, but in reality, it's a little different. So here's another view of it, which I won't go into, but the goal-directed systems have been studied in great detail. Conversational systems, not so much, at least in the way that we like to think of studying and doing research. So again, dialogue systems tend to have, as I mentioned, well-defined domains and architectures that sort of, you can kind of draw like that and put a smiley face and everybody would understand what was going on. There's some kind of an input, there's something that manages the dialogue with reference to a domain, and then it sort of says the right things. And in the end, it might tell you when your train arrives, in which case it wins. Social bots tend to be, well, they're not well defined, and I might be overstating the point, but the system diagrams tend to be a bit more complicated because there are many sources of many levels at which computation is taking place. So on the input side, well, there's intents and topics, but there's also sentiments, entities. You have to figure out co-reference. And actually stuff you could sort of finesse if you're doing a straight dialogue system. So one thing is different is the range of input information has expanded. If you look at what people have been doing recently in conversational systems, and my point of reference is the ones that have been developed as in the context of the Alexa Prize that's been sponsored by Amazon, is most everybody at some point has a finite state machine that manages components of a dialogue. So it might be keyed to the introductory part, might be keyed to a particular topic, but actually what ended up happening is these episodes, if you will, in a dialogue were crafted as FSMs. That's not entirely true because some people just sort of plugged away with sec-to-sec models, and which actually doesn't, as one of the slides pointed out, really doesn't work that well. But in any case, another feature is that you would have a lot of response generators, and then there was some process for picking out just the right response and giving it back to the user. So in some sense, it's all kind of more complicated. So just to recap, these systems actually have no particular goal or particular reason to interact with you. They're just there to have a conversation, and it's hard to define exactly what would be going on. But it also presents some problems. You have to be able to engage in a number of topics, and you have to have human-like conversational skills, if you will. So from our perspective, the work is shifted to try and understand what I have here is the mechanics of conversation. It's something we're all really good at. I mean, you can walk into a party and if you're reasonably social, you can have a whole evening of conversation. It almost doesn't matter what you talk about. You probably forgot all the stuff you talked about, but yet you knew how to manage those conversations, and I think that's sort of the cool thing. So people have been looking at this for a while. In particular, there's this fellow Ventola from several decades ago who came up with a way of coding or describing conversations. Unfortunately, he was kind of one of these social linguists, so there were like maybe 2 or 3 conversations that were analyzed. So take that with a grain of salt. But I think kind of the general idea of a conversation having a set of phases is still very much correct. So, you have to say hello, and then you have to say goodbye. You have to figure out what you're going to be talking about, then you talk about something, then people get bored and they go on to talking to something else, and so on and so forth until it's time to leave. So I think kind of the kinds of systems we build will have to have some level of representation that mirrors this kind of organization. There needs to be a high-level plan for the conversation. So having said that, what I'd like to do is talk a little bit about some of the data that we've been looking at. So the first thing is, or the first one, is something that I ran across at during one of the WOCHAT workshops. And so this involves a bunch of what today we would call earlier kinds of contemporary chatbots. And this was a bunch of systems who were tested with, if you will, with panel of users, and then annotators came by and rated the output on a turn-by-turn basis. And they used 3 labels. This was a valid valid response, an invalid response, and something acceptable, which was kind of, somewhere in the middle. So one of the papers talking about about those results came up with something rather interesting, I thought, which was basically people would agree on the valid. I'm not going to really go into the details, but basically the bottom line is people would agree on valid and invalid, and there was a whole bunch of disagreement about acceptable. So different people had different criteria for what seemed to make sense in the context of a conversation. So one way to understand that is maybe these kind of valid and invalid dimensions are not really enough to tell us something interesting about the state of a conversation. So what we tried to do accordingly is to dig a little deeper into what was going on. So this is an example of the data that was dealt with. I'm not going to read it through, just however to point out that the stuff in blue is the kind of annotations that were applied by the judges. And the system is actually one that was created by Jo Yu when she was at CMU, but I used it because, it's from CMU. But anyway, they all look kind of like that. So what we actually did is we took these conversations, we put them up on Amazon Turk, and we asked people to do a couple things. One was use a 5-point scale, because for some reason we thought that 3 points wasn't enough, although in retrospect is kind of along the wrong idea. But the other thing that we did was ask them, okay, you gave us a rating, now explain why you gave us this rating. And then it started to get a little interesting. So here's an example of again, I'm not going to go into detail, of some of these utterances or responses and the kinds of comments that people made. So each one of the lines around here, if that thing is showing, is a comment. Now, if you kind of just look at it and see what seems, try and find what seems to be operative in the comments, it's something that I would characterize as the system happened to be following the rules of conversation. And this is something like, if I ask you a question, you really should be doing something or coming back with something that corresponds to an answer or has something that relates to what I said. And if you look at the comments, they're basically answers the question, does not answer the question, or they're hard to say, or stuff like that. So one key observation is that when people try and kind of characterize a conversation, one of the things that's important is whether the interlocutor that you're interested in is actually, following the rules of conversation. And so this is one example. I'll show you one more example that has to do with the role of acknowledgement. And so again, there's a bunch of responses. And for a couple of them, for the is what the system first does is says, okay. And in some cases, that's fine. They actually go on and answer the question. In other cases, the system basically kind of ignores what the user says and goes off on a different topic. But in the case where it prepends an okay, it's okay. When it doesn't and just barges ahead into a new topic, the humans don't like it, or rather the human annotators don't like it. So again, it's not like you always have to do exactly what the interlocutor wants, but you have to acknowledge what they were doing. So if they ask you a question, you have to acknowledge that. It's okay to deflect it, but again, it's important to tell them that you're paying attention, if you will. So anyways, I think kind of, if we look at what's actually happening in conversations and why people like bits of it or not, we'll start to identify some of these, rules or skills or mechanics of conversation. Now, having presented that, what I like to do is to go on and talk a bit about blended conversation. So as I mentioned earlier, human conversations actually have a bunch of stuff going on at the same time. We could be, collaborating on a task, like fixing something. There's probably some relationship management going on, like I'd like us to be friends, or I'd like to, tell you, wow, that's a good idea, and just generally maintain a relationship. Or if nothing else is going on, I could do social things like, well, the weather was really nice yesterday, or whatever it is that people do to just talk. But a real conversation has all these strands in it. It's not just about finding out when the next plane comes in, or some such. So one question that comes out of that, which I'm not sure I'm going to be able to answer, is what's an appropriate architecture for these kinds of systems? Is it a single manager that tries to figure out exactly what to do, or do you have multiple managers for each goal stream, and then something that tries to do fusion or selection? In the end, there's only one thing that you can actually speak, and something has to figure out how to reconcile that with the plan, if you will. So now I'm going to hopefully take not too much of a detour and talk to you about some recent work we've done that was based on the Facebook corpus for negotiation. So I think most people here are familiar with this, at least in passing. So basically, what they did and what we did is train a system that could negotiate with a human to partition objects that have different values to the two participants. So we wanted to work with negotiation, so we got the corpus, that's great. We replicated their model, found that you could actually do better with a few tweaks, and so forth. However, when we looked at the data, one of the things we noticed is that although the instructions were very specific, don't fool around, just negotiate, don't talk to each other. About 2 or 3% of the sessions actually had what we would characterize as social chat. Actually, you can start differentiating the kinds of things that people put into it. So, for example, in the first case, the P2 is trying to build a bit of rapport with P1, and if you get P1 to like you, maybe he'll give you a better deal, and the kinds of things people do in negotiation. There's also another kind of thing where really this it kind of sounds social, but actually it's a task gambit. So what the person is saying there, I'm done, I want to quit. But they don't say that. They kind of, make it sound social somehow. That's kind of interesting. So this is, well, let me go on. So one thing that came out of this is work by Ran Zhao, one of my students, where he's explicitly looking at this thing of how can you manipulate the relationship by using the social channel. I won't try a system description because, you know, it has a lot of boxes and stuff. And you can imagine what most of them probably do. So in his particular case, there's a task module that picks the next move according to this model that he built. And then there's something that kind of, so to speak, lards it with social stuff. So what's interesting is that, and I found this kind of mildly surprising, if you start sticking social stuff in, and this might be something like, wow, that was a good move, or really any number of things, performance goes up on, people like it better, but I think more importantly, the objective measures of performance are affected. So in this particular case, let's see, the person wins more. I forget exactly what deal rate is, maybe somebody knows, but it doesn't matter. The dialogues are kind of the same length. People talk a little longer, which maybe is expected. And if you measure sort of the objective quality of the solution that comes up, it's actually better than in the default case. So actually, we're talking about columns 2 and 3, or numeric columns. So that was really interesting, because I think now there's a way of, you now have a paradigm where you can start tweaking all this social stuff and see what kind of effects you have. So you can, you know, build an agent that's real friendly and supportive, or you can build one that, you know, actually isn't and sort of is snide and scornful. What would that do? Does that make you perform better, worse? I don't know, but maybe we can look at that. And then there's just other stuff you can do, like look at this stuff longitudinally. So I think in this case, people play like a half a dozen games. But what if you had them play 60 games in a row? Then you can start manipulating the nature of the relationship over time. So we're kind of hoping we can see how introducing a social stream into the conversation actually affects. Well, it does affect it, but can we quantify it and can we play with it? So this slide really has to do, I still have a few minutes, 5 minutes, okay. So here, onto a slightly different topic. I want to talk about conversational acts per se. Now, some people might think this is awfully close to the damsel stuff from actually a while ago. Basically, dialogue act annotations that were used to represent what was going on. The interesting thing about damsel is, although it was meant to be a generic abstract formulation of such things as dialogue acts, it turned out that, among other things, different domains had different distributions of these acts. If I remember correctly, the switchboard domain had 40% of the utterances were declarative, which, you know, at some point becomes not so useful. And the other thing that happened with damsel is people started inventing domain-specific dialogue acts because they actually made a whole lot of sense. So I don't think that's the right approach, but there's still something abstract going on. And again, it's something that I'm just calling conversational acts. And to try and start to get at it, what we did is use the Phoenix parser, which is a semantic parser from a while back, and built a grammar to parse conversations that were generated within the Alexa Prize system, our system. And the idea here was not so much to build a parser for this stuff, but to try and understand what was the composition of conversation acts in that kind of system. So this is a little bit of detail about it. The only thing to note here, if you look at the cumulative percentage of stuff, kind of sadly, like with most of these systems, there's a lot of yes and no's. And there was something called the Amazon system, NLU, referred to as a catch-all intents, which is basically they didn't quite know what was going on. So we took a look at that particular category and tried to spin it out in terms of conversation acts or conversation moves, if you would. And what we found is, again, I'm not going to try and go into it, but there's actually this layer of description that turns out to be quite useful. So some of the things that came up earlier, like, you know, what if the person doesn't like what's going on? Well, they can reject whatever you said, or they can make some kind of comment that in fact could be seen as a reaction or as a hint as to where the conversation should go. So I think for open domain dialogues, this kind of framework is probably, well, I don't know for a fact, but I think it's really worth exploring. If we look at, this is just here, if we look at the residual utterances, they mostly tend to be topical and very context specific, not so much conversational acts per se, which I think makes sense. So in conclusion, I think the work that we've been doing, particularly the shift in focus to conversational systems, has been really interesting. I think we're getting closer to what it means to have humans and computers or agents talk. And I'm done.
You were contrasting goal-oriented with social stuff, which was a bit hand-wavily vague. I would contend that the social stuff is just much broader and multiple set of goals, but it's still goal-oriented. There are a few things like be interesting, establish a sense of cooperation,
I completely
et cetera. And so then it seems to me that one implication would be then to think about how you chain from these high-level goals through knowledge that the systems don't tend to have today, but could have, about how to achieve, what are paths to achieve those higher-level goals, as well as then to orchestrate an agenda where there are multiple goals and you're interleaving in a sequential interaction. So I'm just kind of curious, where do you think that should go practically?
I agree. So on the last thing that you said, I would characterize it as identifying the skills that an agent needs to have in order to pursue these kinds of goals. And one of the things I mentioned a little earlier on is that it doesn't have to be just social, trying to be friends with somebody. It could be persuasion. It could be, there's a whole long list of reasons we talk to each other. Not all of them have to do with being social or trying to get something done. So I think really what all this blending stuff should point to is that there's actually kind of an array of goals that may be active at any one point in time.